everybody. In this tutorial video I will talk about data pre-processing. For preparing data warehouse, data from operational sources will be extracted, and we know that real-world database can contain noise, inconsistencies, redundancies in data. If the quality of data is low, then the quality of mining results will be also low. So data processing of the extracted data extracted from the operational sources is necessary. There are several data pre-processing techniques: data cleaning, data integration, data transformation, data reduction. In case of the data cleaning, noise, incorrect, inconsistencies are removed. In case of data integration, data from different sources are unified or consolidated in single database. In case of data transformation, data given in one format on one range is converted into other form. Data reduction, the volume or size of data is reduced. Now let's see an example for this incomplete, noisy, inconsistent data. Here I have created a simple table. In this table we can see the age for this. Record number 4 and record number 6 are missing. That is example of missing value. Similarly, we can see for the attribute gender, in some records yum is written, in other records male is written. In record number 3 it is yaf, in record number 5 and 6 it is female. Humans can understand these things, but this thing cannot be understood by computer software system. So that is inconsistency. Similarly, the spelling of Kathmandu in record number 6 and record 5 differs. So this is another inconsistency. So we can see some problem within the data. In case of the address also, somewhere full name of address is given, somewhere abbreviations are given. These kind of things exist within the operational source system. So these kind of anomalies that exist in the operating system needs to be eliminated. So let's talk about data cleaning. Data cleaning routine attempts to fill missing values, correct inconsistent values, smooth noises. In this database table, if we have to fill this missing edge, what we can do is we can take the averages of these values and provide that average value for this missing cells. Or what we can do is we can fill in the missing values manually, but that will be a very time consuming process because we have to find out those values first. Another thing what you can do is, if there are lots of records and there are few records where values are missing, in that case we can ignore those tuples. That means if there are thousands of records and 5-6 records are having missing values, in that case we may ignore those 5-6 records. We can use global constant to fill in the missing values. We can use attribute mean according to the class. In the records we can find class to which those records belongs, and from that class we can extract the mean and provide that mean to the missing values. Or what we can do is we can use the most probable value for the missing values. Suppose the most probable value for the age is 26 in this case. So what we can do is we can write 26 here, we can write 26 here. So in this way we can do the cleaning of the data. Now let's see how we can handle the noisy data. Noisy data are random error or deviation in data. Techniques for removing noises are binding. First one is the binding. In binding, data are sorted and smoothed using the taking average or considering the neighboring data. We can smooth the data by using means, medians or boundaries. Here I provided a simple example. Let's suppose we are having these values 1, 2, 6, 9, 55, 66, and we can see that these values are fluctuating. So what we can do is we will be creating 4 bins containing 4 items each, and we will be replacing values in each bin by the average. Here the average of 1269 is 4.5, so we will be replacing all these values 1269 by 4.5. Similarly, in the second bin there are 55, 66, 87, 99. We will take the average of these 4 values. The average is 76.6 0.75 and replace all the values by this average. Same thing can be done with the another bin also. So in this way we can smooth the values. We have some confusion with the value whether these values are correct or no. So in that case we can do the smoothing of the value either by taking the mean, median, or we can compare with the boundaries which value is nearer to the boundary. In that case we can take 1 and 9 as the boundaries, and 2 is nearer to 9. 2 is nearer to 1 than 9, so we'll replace this 2 by 1. 6 is nearer to 9 than 1, so will 6 will be replaced by 9. So this is example of smoothing by boundaries. So regression is another technique to handle with the errors. Regression fits two attributes by finding best line deviation between line and attribute are reduced. So using the regression line we can eliminate the noises within the data. Clustering is another method. Noise can be considered as outliers, and clustering groups objects with similar properties in one group. So we can eliminate those records which do not lie in any cluster. Binding methods can be also used for data reduction. We can remove the redundancy, the repeating values with the help of binding methods. Concept hierarchy can be also used. If we have some confusion with the data, we can map the data to higher level using the concept hierarchy. So by using the concept hierarchy, we can also smooth the data. Now let's talk about data integration. We already know that data warehouse is integrated collection of data. Data from different sources are integrated to form coherent data source. There are a number of issues to consider while integrating data. Data are brought from different sources. It is not necessary that all those sources have the same schema. All those sources have the same name for the entities. The schema means design of the database may differ. So these are the problems that we will be facing while integrating the data. Number of attributes in the entity may be different. Suppose in one source the customer table is there, in another source also customer table is there, but in the first source customer are having 5 attributes, in the second source customer having 9 attributes. In that case it will be difficult to integrate. So what we have to do is we have to convert the schema into one acceptable schema. Either we have to remove those 9 attributes given in the second source to 5. In this way we can integrate. In some cases attributes name may also differ. In one table member ID is written, in another table member name is written. So it will be difficult to integrate the data if the attributes are having different names. Data redundancy. Same data is represented by 2 different attributes. This can be detected by correlation analysis. For example, just for example, I am considering here expenses and incomes may be correlated. The expenses of the people may depend upon income. They will expend money according to their income level. So one attribute, income or expense, will be sufficient to consider. We can remove expense or income, consider only one. Data value conflicts means in different sources attribute data types may different, attributes value may different. For example, in case of the weight, in one source weight is given in kilogram, in another source weight is given in pound. So pound and weights are different units. This also makes schema database integration a problem. Data transformation. This is another process of data processing. Data in one format is transferred to another format. Means suppose I already given the example of weight. Weight given in kg can be converted to pound, or weight in pound can be converted into kilogram. That means we can transform the data given in one format to another format. That is the job of data transformation. Data transformation involves following: smoothing. Binding method transform data according to its neighbors. I already explained that in the previous slide. Aggregation. Data can be summarized to higher level. Daily sales can be aggregated by month or week. So we can use the concept hierarchy to transfer data given in lower level to the higher level. Data can be normalized. Data is scaled so that data falls in specified range. That is the idea behind normalization process. Suppose age is given in 3 digits, maximum age can go up to 3 digits, but what we can do is we can map age into 0 to 1 or -1 to 1 or on some specified range. We can construct new attributes from existing attribute. If date of birth is given, we can construct age. Now let's see the data normalization. Min-max normalization is one of the technique to transform the data from one range to another range. Let's suppose we are having old value, that is v equal to 25, old minimum 10, old maximum 100, and the new range is 0 to 1. So the values given between 10 and 100 are to be mapped to 0 and 1. For that we can use min-max normalization. This is the basic formula. You can see the formula written here. V dash equal to v minus mean a divided max a minus mean a, and so on. So using this formula we can convert the data given in one range to specified range.
Method for converting data given in one range to another range. Basically, decimal scaling is used to convert given data into the range of 0 to 1. Let's suppose we are given with the data within the range of 441 to 9876. In this range, the maximum value is 9876. So each value within the range will be divided by 10 to the power 4. Here the value of j is equal to 4, as the maximum value 9876 has 4 digits only. So each and every value within that range will be divided by 10 to the power 4 and we will get the transformed value. So in this way we can use decimal scale method to transform given data.
Data reduction. Data reduction reduces the given data set to smaller size data. We know that data warehouse is big in size and high volume data will take more time for processing. So if possible, we always have to think how we can reduce the volume of the data so that our data mining algorithms can work efficiently. Strategies for data reduction: data cube aggregation. Data given in weekly base is reduced to annual base. We know that weekly based data will be higher. There were lots of records if we consider on the week, but if it reduced to annual, the volume of the number of records will be reduced. Attribute subset selection. We can remove irrelevant attributes. For example, age and date of birth are given. In that case, we can only consider age and remove date of birth. Another technique for data reduction is dimensionality reduction. Data encoding is done to reduce the data. Suppose hobbies, spelling mistake, no problem. Suppose hobbies are movie, reading, roaming, sports, can be coded by A, B, C, D. We can represent movie by A, reading by B, and so on. So one single character is sufficient to remove these hobbies. Similarly, another method, numericity reduction. Data can be represented with a smaller alternative form. Here Kathmandu can be represented by KTM, Bhaktapur can be represented by BHK, Patan by PTN. So we can use the abbreviations for words. In this way also we can reduce the size of the data. Another is we can use the concept hierarchy to reduce the data size. Thank you.